Hello everyone, how are you all? I hope you guys are pretty well. So, in this video, we are going to discuss about line integral. And before starting this video, I wanted to tell you that we are going to discuss about entrance examinations and related questions. So, actually, we have to wait for it. And after discussing all the topics related to vector algebra and real analysis and also many more, we are going to discuss about the questions related to entrance examinations. Okay? Okay, so let's start with this video. As you can see in front of your screen that we have assumed a position vector which is xi cap plus yj cap which is equals to f vector xy. This is actually a general form of a position vector and it may vary from question to question. So let's say that with the help of this position vector, we are able to draw out the continuous curve that you guys can see in front of your screen. This is basically a two-dimensional curve. Suppose that we need to find out the line integral of this continuous curve. So what we are going to do here is that we will use this formula. With the help of this formula, we will get to the line integral from the initial point which is x is equals to x1 to the terminal point which is x is equals to x2. Here you must have noticed that we have used some dl. So I tell you that what is this dl? This is simply a representation of a partial dx and dy. Maybe you are a little confused, but all doubts will get cleared within a few minutes. Let us assume a position vector 2x I cap plus 4y j cap which is equals to f vector xy. And let's say that this is a position vector in a form of a speed of a bus which has traveled some distance under this position vector. So to trace its path, what we are going to do, we will plot its points on this graph. Suppose that the trace that this bus has covered is x is equals to minus 2y. So we will collect its points from minus 4 to plus 4. So let's say if we substitute x is equals to 0, then we get y is equals to 0, which implies that we are getting an ordered pair of xy which is equals to 0, 0. Okay. Similarly, if we substitute other points starting from x is equals to minus 4 and ending with x is equals to plus 4, we will get other points also. Okay, so you can pause the video and just simply verify your points that you have substituted in the equation x is equals to minus 2y. Okay, so you can see we have collected many points here. Okay, now it is time to plot these points. So let's say we first plot the point 0, 0. Here it is 0, 0. And similarly, we will plot other points also, which will form a trace that you can see in front of your screen. Okay, so this is the trace. Suppose that this bus has been covered from x is equals to minus 4 to x is equals to plus 4. Okay, now we come back to this position vector. And since this is the speed and we need to find out the distance, so we will use the formula of speed is equals to distance upon time. Since we need to find out the distance, so we get that distance is equals to speed into time. Okay. So since this is speed is actually f vector xy, so we will write f vector xy in place of speed. and let us say that we are considering dr vector as the time. Okay, so now what we are going to do, we will actually consider dr vector as dx I cap plus dy j cap. This is a vector. Okay, and now we will substitute this dr vector in this place. Okay, and similarly we will substitute this f vector xy in the place of speed. Okay, so what do we get here? We get distance is equals to f vector xy dot dr vector, which is further equals to 2x I cap plus 4y j cap dot product with dx I cap plus dy j cap. And since that we have discussed about dot product and cross product in our previous video, so from that we will take that I cap dot I cap equals to 1, which is equals to j cap dot j cap, and I cap dot j cap, which is equals to 0, which is equals to j cap dot I cap. And after solving out for the dot product of these two terms, we will get the distance, which is equals to 2x dx plus 4y dy. Okay. Now, if you put your attention towards this distance, then you will find out that this is actually a partial distance, okay, which we will represent as dt. Okay, why this is a partial distance? Because of the presence of these partial terms, which is dx and dy. Okay, so now we are going to write dt, which is equals to 2x dx plus 4y dy. So now we will find the integral of this partial distance, which we will consider from x is equals to minus 4 to x is equals to plus 4. Okay, now if we come back to the graph that describes the trace of the bus, which is from x is equals to minus 4 to x is equals to plus 4, so with the help of it we will be able to find out the distance of this bus. So numerically we will write it as integral from x is equals to minus 4 to x is equals to 4 dt, which is equals to x is equals to minus 4, terminate to x is equals to plus 4, and we have just written 2x dx plus 4y dy in place of dt. Okay, so after integrating it, we get that this integral x is equals to minus 4 to x is equals to plus 4 dt is actually the total distance that the bus has covered. Okay, now do you remember that we have considered the trace from x is equals to minus to y? So if we take the value of y in terms of x, then we get y is equals to minus half of x. Okay, now we will substitute this value in this term. Okay, now you will think that what we are going to write in the place of this dy. So for that we will use differentiation, and we will differentiate y is equals to minus half of x. You can pause the video and check the differentiation here. Okay, so after this we will simply substitute this dy into the integral. Okay, therefore we get the integral as you can see in front of your screen. We have simply substituted y and dy into the integral. Okay, so after cancelling out the common terms, we get towards the integral 2x dx plus x dx, which can be written as integral x equals to minus 4 to x is equals to plus 4 3x dx. Now, since 3 is a constant, so we will take it as a constant term and we will put it outside the integral. Okay. Now we will consider this integral. Okay. So what we are going to do, we will use the formula of the integration, which is integral of xn dx. This is actually equals to x to the power n plus 1 upon n plus 1. And since we are having an integral of x to the power 1 dx, so it can be written as x square upon 2. Therefore, if we substitute it into the integral, we get 3 into x square upon 2, and in this we are going to substitute x is equals to minus 4 and x is equals to plus 4, like so. Okay. After solving it out, we will get 2 the integral equals to 0. Okay. So what does this mean that the integral is coming out to be 0? This means that this bus must have traveled a distance of 4 units into forward direction and it must have come back in the same direction with the same unit. That means that the integral of the distance is 0. Okay? So here comes a question. Since we are able to find out the distance of this bus, we need to find out the displacement of this bus. As you can see that there is a common difference between distance and displacement, and you guys must have noticed that in many of your classes. Okay, so I would ask you guys to write the displacement of this position vector, okay, that this bus have traveled. Okay, and I will be correcting you guys in the next video. Okay, so do comment on the displacement of this bus. Okay, I hope you like this video. More conceptual videos are on the way, so please like, share and subscribe to my channel. And if you have any doubts related to this video, then you can write that down in the comment box below. Or if you want to know about different topics, then also you can write that in the comment box. Thank you.